Today we are continuing with rectangles and moving on to rhombi and squares. Problem number 32. There is a point on problem number 32 that you can find that has an ordered pair in the top left-hand corner. So look at problem number 32. What is the ordered pair in the top left-hand corner of your rectangle? Negative 4, 1. So right here, I'm going to write negative 4, 1. Notice I have graph paper right here. You can certainly use graph paper. In the bottom right-hand corner, what is the ordered pair for the rectangle in the bottom right-hand corner of problem number 32?
5 and negative 3.
5 and negative 3. 1, 2, 3, 4, 5, and a negative 3. So we have a 5 and a negative 3. Now, in this rectangle, you'll notice there is a segment that goes from corner to corner. What's the vocabulary word that describes going from corner to corner in a rectangle? Nope. How about this? I'll finish the rectangle and maybe you guys will be able to visualize it a little bit better.
Diagonal.
Yes. That is what's called the diagonal of a rectangle. So there's our rectangle. Okay? Just by knowing the two ordered pairs for the diagonal, you should be able to complete a rectangle on graph paper if that's what was given to you. Now, tell me something that all rectangles have. They all have what's in every single corner? Right angles. That's something you need to know. You should already know that, but that's something you certainly need to know. Now, from here to here, that distance, okay, you'll notice that when I take the diagonals of a rectangle, what do the diagonals of a rectangle always do? They always cut each other perfectly in half, which means they bisect each other. So these diagonals bisect each other. Now there's a point right here, everybody. There's a point. What letter did that give you on problem number 32? What letter did they give you right there for that point? Okay. So all you have to do is locate point K. And if you can locate point K, that is the answer to the question for number 32. What is K? If I gave you a definition of K, that is the point that's in the middle. What do we call that? The midpoint, right? Everybody here should be able at this point in their life to know how to find the midpoint. In fact, it was probably your second assignment in Geometry A, called distance and midpoint. Does anybody know the formula to find a midpoint? Remember that?
X plus 1. Or X1.
What do you have to do? You take your x values, you add them together, and you divide it by 2. That's how you find it. By the way, think of it. Midpoint. That's the midway point. That's the halfway point. So you take your x values, add them together, divide by 2. What are you going to do with your y values? The exact same thing. You take your y values, you add them together, and divide by 2. This right here, this is how you find your x coordinate. This is how you find your y coordinate. So here are your, I'm going to highlight your x values right here. You got a negative 4 and you've got a what? A 5. Just lug them in. Okay? Over here you have your y values. You got a 1, you got a negative 3. You take them, you add them together, and you divide them by 2. Now, if you're going to do it in the calculator, you have to be very, very, very careful when you're doing it in the calculator. It's easier to do this in your head than it is the calculator. Okay? So here you got to be careful. Okay? What were my x coordinates? 5 and negative 4. Watch. If I said negative 4 plus 5 divided by 2, this would be an incorrect way to type it into your graphing calculator.
It would just divide 5.
It would do 5 divided by 2, and then it would add it to a negative 4, because even if you don't know order of operation, guess what knows the order of operation? Your calculator. So what do you have to do to make sure you don't screw it up? Put parentheses, negative 4 plus 5, close parentheses, then divide it by 2. So if you're going to do the calculator, That's what you would have to do. Okay? So,
What's the y thing?
oh, it's the same thing. You just take the y values, add them together, and divide by 2. Okay? Now, I'm not going to press enter. All right?
Oh, right.
But right now, what I'm looking for is the ordered pair for k. So you could put a -4 here. You can add a 5, divide it by 2. For the y values, you're going to put a 1 and a -3. You're going to add those together and divide by 2, and you're going to give me the ordered pair. All right, here's a word problem. Right here on problem number 33, it says a rectangular playground. If you're ever working on a word problem and you see the word rectangular playground, draw a rectangle. Just draw it. Okay? So draw a rectangle out right there. It says this is surrounded by an 80-foot fence, which means the perimeter of this rectangular playground is 80 feet. That's the perimeter. That's the distance all the way around the rectangular playground. It says one side of the playground is 10 feet longer than the other side. So if one side is x, the other side has to be 10 plus x. What are the properties of rectangles? Opposite sides have to be congruent. So if that's x, this has to be x. If this is 10 plus x, this also has to be 10 plus x. Okay? So they all have to be, the opposite sides have to be the same. So at this point, once again, what do you have to do? You're going to have to be able to solve for x. So how many x's do you guys see up here? 4. So put 4x plus 20, because 10 plus 10 is 20. And you're setting it equal to 80. So here's the two things you need to do. Don't tell me the answer. First thing you need to do, everybody, solve for x. Step number 2, you better plug it back in. So plug it back in, which means this. Once you figure out what the heck this number is right here, take it, plug it in there, and remember, it says, what is the length of which side? The longer side. So you're looking for the longest side, which I'm going to highlight what the longest side is. Just remember, whatever you get for x, to find the final answer, you better add 10 to that answer so I can give you full credit. Okay? I'm going to zoom out. Right here, guys. Everybody should have all of this totally done. You should already have all the answers for 19 all the way through 33. We're going to be working on the next page now, which everybody in your journal, what I need you to title it in your journal is Rhombi and Squares. We're going to be focusing on the properties of all rhombi and all squares. And I'm going to zoom in right here to these properties. So right now, what I need everybody to do in their journals is to take these properties right here, and we are going to draw a rhombus and a square. By the way, all squares are rhombi, but not all rhombi are squares. So make sure to write these down in your journal right now. All right, the first thing I'm going to do, to the best of my ability, I'm going to draw a rhombus. Now, a rhombus is special because it is a special type of parallelogram. But in a rhombus, all the sides are perfectly equal to each other. So what I'm going to do my best is I'm going to try to draw a rhombus that has all equal sides. Now, there are certain tests for rhombi to let you know if it is indeed a rhombus. But right now, I'm going to label this.
Wait, so I need to draw that right now?
Yep.
Okay.
A, B, C, D. This is just one example of a rhombus. So we'll label it A, B, C, D. Now it says right here, it says all sides are congruent, which means segment AB is congruent to segment BC, which is congruent to segment CD, which is congruent to segment DA. I know that's a lot to say, so here's how quickly you can say it without having to write a whole bunch. AB is congruent to BC, which is congruent to CD, which is congruent D, A. All right, here is a test for all rhombi. Right here it says the diagonals are perpendicular to each other. So if you drew a perfect rhombus, that means that the diagonals have to intersect at a 90-degree angle. Now what does that mean? That means if I draw the diagonal in, right here to here, there we go. That diagonal right there. And if I draw this diagonal right here, what should that form? It should form a right angle. Yeah, next. But the next doesn't have to be a right angle, right? So here's what you can do. Check this out. I'm going to get a protractor. We'll see how close mine is. All right? So here we go. Here's my protractor. So right here, if we check it right, watch what I do. I'm going to turn it. Oh, look, I'm off, aren't I? You see my right angle? It doesn't fit perfectly. So if you were to draw a perfect rhombus, what should this right here be? A right angle, okay? Now, if I had graph paper, I would be able to draw it perfectly because then I could make right angles. So, right here, what I'd like you to do, in your journal, even if you didn't draw a perfect rhombus, label all of these angles right here. Just label them. 90 degrees. I know some of your angles don't even look very close to 90 degrees, but at least label them 90 degrees. It'll let you. There we go. Okay, so make sure, even if your angles don't look 90, make sure you label them all 90 degrees. Because technically, in a rhombus, the diagonals, not only do they bisect each other, but the diagonals make 90-degree angles. Perpendicular to each other.
So it's perfect right angle.
Yeah, exactly. Right angles equal 90. Now, the last thing I want you guys to understand, it says the diagonals do what to the angles? They bisect. It's very important. Right now, everybody, what I want you to do is I need you guys to understand that these angles right here are bisected, which means they are perfectly equal to each other. This angle is equal to this angle. This angle right here is equal to this angle. So right now, what I'm going to tell you, I'm going to give you guys a certain number of degrees. What if I told you guys this was 30 degrees? If this is 30 degrees, then this right here would also have to be 30. This would be 30, and this would also be 30. Which means these angles right here, this angle right here has been bisected, and this angle right here has also been bisected. I'm going to do a couple of tick marks. Or actually, instead of tick marks, it'd be better if I do this. Oh, you can erase it, or you can use tick marks. We'll do double mark. All right? So right here, this would be 60 and 60, and this would be 60 and 60. That's right. So understand, in a rhombus, this triangle is exactly equal to this triangle, which matches this triangle, which matches it. So how many congruent triangles do you have inside of every single rhombus? Four. You have 4 perfectly equal, not equilateral triangles, but 4 perfect equal triangles. All right? All of these, what, add up to 180 degrees, and this segment is equal to this segment. So right now, make sure you guys have that picture. Now, the only thing we're going to do differently now is we're going to draw a square. We're going to show you that all squares are rhombi, but not all rhombi are squares. So we're going to draw a square. Now, I can definitely draw a square. Let's see here. Oh, that's not a very good square because I got to make right. Here we go. There we go. Here we go. I'm drawing a square. Right there. So I'm going to label this square A, B, C, D. Now, in a square, it has all 5 parallelogram properties. It has the 2 additional rectangle properties, and it has 3 additional rhombus properties. The cool thing about a square is it has all the properties of what? All the properties of a parallelogram. It has all the properties of a rectangle, and it has all the properties of a rhombus. which means a square gets to be a part of a lot of groups. So let's say you're a square, and you're walking in a two-dimensional world, all right? And you see some clubs you want to go into, but it says, I'm sorry, only rectangles are allowed. That's okay. No, that's okay. If you're a square, can you go into a rectangle club?
Yeah.
Yes, you can join. Because guess what? A square is a rectangle. All right. Then you walk down the street, you see another club, you're like, oh my gosh. It says only rhombi allowed. Well, guess what? You're a square. Guess what? You're still allowed. You can go in. All right.
Yeah.
Then you go to another club. You're like, you know what? I want to go to the parallelogram club. Well, guess what? You can because you're
Rectangle.
no. Not only are you a rectangle, you are also a square because a square is a parallelogram. A square is a rectangle. A square is a rhombus. You get to go to whatever quadrilateral club you want. There's only one club you can never go into if you're a square. There's only one club. Trapezoid. Can't join the trapezoid club. They have rules all themselves. So that's where you would be banished. You're not allowed to go to the trapezoid club. So right now, draw a square. And if you would, please, in your square, make sure. Yeah, some of you are trapezoids. You're right. Some of you are trapezoids. That's okay. You're off to yourself. All right? But right now, squares, I would say, have the most privileges because they get to do a lot. So they get to join a lot of clubs. So right now, make a square. The cool thing about a square is not only are all sides equal, not only do they have 4 right angles, not only do the diagonals bisect each other and form another additional how many right angles right here? 4 right angles. But squares also break into beautiful 45, 45, 90 triangles. Check this out. That's a 45. 45, 90. That's a 45. 45, 90. These are all 45, 45, 90 triangles. These are special right triangles. We will learn later. But these are special right triangles that have special properties. Okay? But a square has all 5 parallelograms, 2 additional rectangle and 3 additional rhombus properties. We're not going to label everything that's equal, but hopefully you can see how everything is indeed equal. We will eventually. All right, here we go. We're going to use diagonals here. Check it out. This triangle, all 4 triangles are perfectly congruent to each other. Now you have 8 perfect 45, 45, 90 triangles. Whenever you cut squares perfectly with the diagonals, whenever you cut them, what you've done is you've created perfect 45, 45, 90 triangles. You could keep technically doing this forever if you had a thin enough pencil. Does everybody see? All of these triangles right here are now equal. These are all equal. I have how many triangles? 4 here, right? Yes, sir. All right, so we have 4, 8, 12, 16. All right, you can keep going on. By the way, I can keep cutting these over and over and over again. These are called fractals. Okay? All right? Basically, these right here are all going to be the same. So right now, you have every single time you have a square, what are you allowed to do? You can keep cutting them into smaller and smaller 45, 45, 90 triangles. I'm going to stop.
No, I'm not stopping.
Now what we're going to do is we are going to work on the problems right here. Okay? So right here, you look at your rhombus right here. This is a rhombus. it says that this angle right here is 53 degrees, which means that this angle is 53 degrees. This angle right here also has to be 53 degrees. What do these angles also have to be? 53. So label them. What do all the angles in the middle all have to be? 90. Okay, those all have to be 90. So label them. These are all 53. So right here, this angle right here is 53. This angle is 53. This angle is 53. This angle is 53. All the angles that are going in the middle right here, these are all 90 in the middle. Because why? The diagonals are perpendicular to each other. Okay? Which means we have some angles here that are left. All right? So, without having to do a whole bunch of math, how could we figure out the measure of this angle right here?
Add them, and then subtract it from
180. We have a 90. We have a 53. What does this have to be right here? What number plus 53 gets us to 90 degrees? Because 90 plus 90 is 180. 37. So that's 37.
37, yes.
That's 37. That means all of these. In a rhombus, by the way, how many angles did they give us? How many angles? They just gave us one. They gave us one. They said, that's it. That's the only thing they gave us. What do we have to know? You have to know that the diagonals are perpendicular to each other. All right? And then you have to take it away from 180 to get that 37. So right here, I'm just going to do one problem right now. I'm going to do this problem. And this is what you guys need to be able to do on your own. Okay? It says find the measure of angle X, Y, W. So where do I start? X. Tell me where to go next.
W.
So where did I start? X. Where did I go? Y. Then I went to W. Okay. By the way, this is the order right here. This is the order that you go. You start at X. You go to Y. Then you travel to W. What is this letter always going to be? That's going to be your vertex, which means this is the angle that you are searching for. So that answer right there is 53 degrees. That's what you're looking for. You have to know how to find the angles. You have to know this is the pattern. This tells you where to start. This tells you the middle. This tells you the end. So follow that pattern. Does everybody see how I found the measure of this angle right in here? I started at X. I went to Y and I went to W. That's what you have to do.
So if you
Number 36, find X to Z. By the way, X to Z is the distance from right here to right here. Now, over here, it says X to B is 2A minus 2. So from here to here is 2A minus 2. So this distance right here is perfectly equal to this distance. If they say this is 2A minus 2, by the way, this is the letter Z right here. You can't see it, but that's Z. And it says Z to B is 5A plus 1 over 4. These distances are equal to each other. So please, somewhere where you can work it out, do 2A minus 2 equals 5A plus 1 over A 4. Now what makes this problem difficult? It's not the 2A minus 2. What makes it difficult? Because this is being divided by 4. So what would we have to do to make it a little bit easier? Besides not do it. Multiply. Multiply. Good. By what? 4. You betcha. We're going to take this side right here and multiply it by a 4. Whenever I do the one side, I have to take the other side and multiply it by a 4. So this is what I want to see on your paper. 4, parentheses, 2A minus 2 equals. These 4's will cancel out. 5A plus 1. At this point, what you need to do, at this point, you need to do two things. Solve for A plug it in. You got to be able to solve for A and plug it in. If this is a little bit overwhelming, remember, the first step is to distribute. Everybody should have examples of how to solve for A for something that looks like that. You should be able to solve for A and plug it back in. Once you plug it back in, what's your final answer? What are you looking for? You're looking for the distance from X all the way to Z. So once you find this distance right here, once you find that distance, what should you do with your answer? That's halfway across. What should you do with that? Double it. So find the distance from X to B and then double your answer. That'll give you your final answer. Good luck.